So this question gives us the repeated decimal 0.7 repeating. We want to express this as an infinite series, show that it converges, and find the sum. Okay, so 0.7 repeating, what is that? 0.77777, etc. Thinking of them as fractions, 0.7 is 7/10. 0.07 is 7/100. 0.007 is 7/1000. 0.007 is 7/10,000. So that you can see what we have here. Now my first term, a sub 1, the first term in my list is 7/10. What is my common ratio? To find the common ratio, you divide two subsequent ones. What's the next one divided by the previous one? What's 7/100 divided by 7/10? Well, that's the same as 7/100 times 10/7, which is, of course, 1/10. If you want to do the next one, third one divided by the second one, 7/1000 divided by 7/100. 7/1000 times 100/7. The 7's divide out. 100 divided by 1,000 is 1/10. So the first term is 7/10, and the common ratio is 1/10. What do we know? Does this converge or does this diverge? The question says, show that the series is convergent. Well, good, it is. A geometric series converges, which means its infinite sum, if you add them all up, converges if the common ratio is between -1 and 1. In this case, common ratio is 1/10. So the series converges. Now, what does it converge to? What do we know? So again, we're dealing with the 0.7 repeating, which is 0.7777 forever. We said our first term, a sub 1, is 7/10, and our common ratio is 1/10. The infinite sum, when it does converge, is the first term over 1 minus the common ratio. First term, 7/10 divided by 1 minus 1/10. 7/10 over 9/10, 7/10 divided by 9/10, which is 7/10 divided by 9/10, which is 7/10 times 10/9, which is 7/9. So we believe that this converges to 7/9, but I think I can also get that from the graphing calculator. So remember, that's what we're looking for. We're looking for the sum of the convergent series. We believe it sums to 7/9. Let's go to the graphing calculator and see what we get. And I'm just going to put in 0 point and a whole bunch of 7s. I have to go beyond whatever the tolerance of the calculator is, and then say math, change to a fraction, and hopefully it'll come back 7/9, and it did.